Welcome back to the Network Engineer Diaries. I'm your host, Jimmy Shaka. Today we are going to talk about network address translation, NAT, the purpose of NAT, and how to configure NAT on a network. The Internet Engineering Task Force, IETF, documenting the standards using the request for comment, RFC 1918, defined a range of private IP addresses to be comprised by these ranges: 10.0.0 all the way to 10.255.255.255 and 172.16.0.0 all the way to 172.31.255.255 and lastly 192.168.0.0 all the way to 192.68.255.255 and public IP addresses to be all the remaining IP addresses other than the private IP addresses. For an organization to be able to use public IP addresses, that organization or the company has to pay for those public IP addresses. But private IP addresses, if a company wants to use these IP addresses, they don't have to pay for these as long as they're used within the organization. But if a company wants to send traffic outside via the internet, it's going to require a public IP address. It's going to have to pay for that public IP address from a service provider. Originally, they did not forecast an explosion in the internet growth. So they had originally allocated about 4.3 billion public IP addresses, and they thought those were good enough for the whole world. Fast forward to 1995, people started to notice that those public addresses of 4.3 billion IP addresses were not going to be enough. So a workaround was developed to be able to fix that. That's where the network address translation came in. With network address translation, NAT, a company can use a bunch of private IP addresses within the organization inside, and then only use a handful of public IP addresses to communicate with everything else outside the organization. So we have these three types of NAT, network address translation. There is Static Nat, Dynamic Nat, and PAT, port address translation. Okay, today we are going to talk about Static Nat. We have this network topology here that consists of 4 computers down here, a switch, 2 routers, R1, a switch, switch 2, and an internal server, server 1. This is inside the organization, and then outside we have a service provider, let's say like AT&T or Suddenlink. This service provider router provides connectivity to the internet. The inside organization connects to the public domain via this service provider router. Our internal organization, our company, has purchased these IP addresses: 200.55.110.0/29 subnet. That gives us 6 usable host IP addresses, going from 200.55.110.1/29 all the way to 200.55.110.6/29. So we have a total of 6 usable hosts. We went ahead and configured our devices as per our topology here. We configured the first IP address we purchased from the service provider on the service provider interface fast Ethernet 0/1 with IP address 200.55.110.1/29. Within our internal organization, router 1 on the fast Ethernet 0/1 interface, we configured 200.55.110.2/29. That leaves us with 4 more usable hosts. Our next public IP address is 200.55.110.3/29. That's what we are going to configure with our static NAT, network address translation, for our internal server here. We want our server to be able to reach the external server, server 1, at 200.55.110.12/29 in the public domain. But right now, because we are using private IP addresses inside our company, we cannot send traffic to the public domain because private IP addresses cannot communicate with public IP addresses. In order for that to happen, there has to be a network address translation in between to be able to facilitate that. Before we do that, let's verify that there is no connectivity between our servers, internal server and our external server. So let's ping our external server at 200.55.110.12. See, our destination host is unreachable. Now, let's go back and configure our network to do the network address translation in order for our internal server to be able to reach our external server. Also, before we do that again, you can verify that if we try to reach the internet, it's not going to work because there's no connectivity going from server 1 all the way to server on the external network. See, our request timed out. So let's go back to work and configure this static NAT. The way you do that, we come here on the router 1, go to the global config mode, interface fast Ethernet 0/1. That's the interface facing towards our public service provider router, okay? And we're going to say IP network address translation outside, okay? And then back on that interface facing our internal server, interface fast Ethernet 1/0, IP network address translation inside. Next, we're going to say IP network address translation inside source. Static, let me expand this, static translate 10.0.1.10 to the public IP address 200.55.110.3 because that's our next available IP address that we have purchased. Okay, we're done. Should be able to reach the external server now. Let's try that again and see. Let's try to reach the web page on the external server 200.55.110.12. See, it's working now. Cisco Packet Tracer web page. See, it works. That's great. You can also show that there's ping connectivity. Obviously, 55, 110, 112. We're pinging the external server using our internal server. See, there's connectivity. Now, if you go on the router, you can show IP NAT translation. You can see what translation took place. You can see that our internal host 10.0.1.10, which is server 1 on the left hand side in the upper corner. You can see that 10.0.1.10 was translated to the public IP address 200.55.110.3 and it was sent out to the public IP address 200.55.10.110.12, and that is our external server. So that's great. And that was the first traffic we had. The second one was reaching the web page, the internet. You can see that our server 10.0.1.10 was not translated to 200.55.110.3 and it was sent to the public IP address 200.55.110.12 and it was intended for port 80, which is the World Wide Web, the internet. So that's good. So that's how you check our translation table on the router. Also, you can turn on debug IP NAT. You can turn on the debug function and you can visualize what's happening as it happens. Let's try this again. Let's go back on our request for a web page, access to the web page. Let's do that and run fast on our router. See, we can catch in real time what's going on with the debug function, debug IP NAT. You can see that our source IP address, which is 10.0.1.10, was not translated to 200.55.110.3, and it was intended for our destination IP address, public IP address of 200.55.110.12, which is our external server. So that's great. Okay, so that's how you set up Static Nat. I'll see you in the next video where we discuss Dynamic NAT, how we configure Dynamic NAT.